Hello and welcome back to part 2 of following along with Unity's beginner code series. In this video, we're going to start off with some theory on expressions and variables, and then we'll start creating our own functions. We'll take a look at the project structure itself so we know how to intelligently create our own usable items and item effects, and then we'll do the homework for week 2. Okay, let's get started with the theory. Let's start by creating a new folder inside of assets, and we'll call that scripts. We're just going to put all of our scripts inside of here. So inside here, I'm going to create another folder for my examples. Okay. I'll create a new script. Name it expressions. And you always want to name your scripts with a capital letter. Okay, let's open it up. Okay. So as you see, it gave us a public class inside automatically with the same name as the file name that we just gave it. Okay, and it automatically extended model behavior for us, brought in these using namespaces that we talked about last time. And here's our start function that we saw from last week. Okay, and it also gave us the update function that I mentioned. Now this is our game loop. Okay, it begins by going in, it starts with the start function, and once that is done executing, it goes into the update function and continues to loop through there. You know, those are the two most basic functions you're going to want to use. Another one is awake, and I don't believe we're going to use that in this video, but if we do, we'll do. Okay, we're going to concentrate on the start function on this script though. Okay. All right, so let's just imagine we need to call some variables here. Okay, so we declare a variable x with a keyword var. We give it a name x. The assignment operator equals, followed by an expression. And the most basic expression will be an integer variable. Okay, and we want to follow that up with the semicolon. That's the basic syntax, or in other words, the way it's written of the variable declaration. Okay, and we'll talk about that here in a little bit. Okay, but for now, we've declared a variable with a generic type. We've given it a name of x, and we've assigned it to the value of the expression 89, which, well, the expression is actually a value itself, and we'll talk about that shortly too. Okay, so next we want to create another variable, and we'll name it y, and assign that to, say, 16. Okay, and then we create another one. Let's just call that z, and then for the expression, we're going to give it x plus y. Okay, and then that will actually equal the sum of those two numbers. Okay, so let's just take a quick look at what's going on here at a little bit of a deeper level. What's happened here is we've actually created two separate environments here. Before the program is compiled, it creates what we would call, this isn't a technical term, we'll just call it a static environment. Okay, and inside of that static environment, we have a variable with the name x, and it has a type of the value here, so it will be a type of integer. So a variable type integer inside of our static environment. Okay, now after everything compiles and type checks, it's going to go into a, we can run the program, and then while it's running, it's in what we would call a dynamic environment. Okay, dynamic environment now has a variable x, which points to a value of 89. Okay, so there's our two separate environments. Okay, and this continues the whole way down our code. Let's clean this up a bit. Okay, now on this line, before it compiles, before we run it or anything, our static environment has to type check our new variable. We have a new variable now. We have a y, and it is a type int. Okay, the value types to an int, so the variable is of type int. So y of type int and x of type int. Okay, and now in our dynamic environment, we've got our new variable y, which points to the value of 16. Okay. And then we can go down here. Now we've got a new variable declared, and it's named z. Now the only reason that this can have a type of int is if this type checks and returns an integer to it, okay? And since x is an int and y is an int, the addition expression will return an int as its value. So z now has a type int, okay? And in the dynamic environment, z points to 89 plus 16, which would be 105. Okay. So there's our environments. That's what's going on behind the scenes here, you know, and this might seem kind of basic, but you know, it's really good to understand this now so that when you start doing more complex things that you understand, you know, what's really going on behind the scenes. Why isn't my code type checking and or compiling? You know, it's much easier to understand if you know how it works, you know, and then while it's running, you know, how does the environment change while it's running? Okay. So, and another thing I want to mention here, it's actually very poor style to put var here. We want to declare all these as ints. We know they're ints. Let's go ahead and make them ints. Okay. That's what they are. And they do type check. Okay. So there's that basic theory there. And that's it's just important that we understand that now before we start talking about, you know, more complex things later. Okay. So looking more at that, and I really want to call out this this course here on Coursera, Programming Languages Part A. It's actually a 3-part series. The theory we're using is actually part of what you'll learn in the first part, and I highly recommend it if you are, you know, interested in learning more about how programming languages work, you know, at the core. And if you do follow through with the 3-part series, you end up actually creating your own, implementing your own programming language, which is really fun. So let's take a look here. So we've looked at values, and we know now all values are expressions. Every time you have a value, that is an expression. Okay, but not every expression is a value. Sometimes an expression might return an error, or it could return an infinite loop or something else undesired. But you know, every value is an expression. Every value evaluates to itself in 0 steps. Okay, that means that it takes no time. Okay, it takes no time to evaluate a value to itself. You know, here's some examples. You know, 34 and 65 are both of type int, and they would evaluate directly to that value right away. You know, 3.14. If you put an f behind, it will become a float. Now, without the f, it would actually be a double, which you could find use for that. Most times you'll see floats and integers, but doubles are out there too. And then you have true and false. Now these are built-in values. These are constants. Actually, is what we would call them. They're constant values of type bool. That's a Boolean value, true or false. Okay, so that's values. And we've looked at expressions. Okay, let me get that out of the way here. We've looked at expressions. We've looked at syntax, which is how it is written, and we've also looked at the semantics, which is what it does. Okay, and the semantics can be broken up into 2 separate parts, you know, our type checking and our evaluation, which we saw inside of the static environment, which does our type checking for us, and our dynamic environment, which does our evaluation for us. Okay, so the syntax for an expression in C# is the expression itself followed by a semicolon, mostly. So if it's followed by a semicolon, it means that it is a statement itself. Okay, it could have sub expressions inside of it, like like shown here, like E could actually be something like this, where it has an expression 1 inside of, inside of an expression, an addition expression with another expression. You see what I'm getting at? It could be nested inside of all of this, and this could be just called E as one expression, okay? And the way we type check an expression is that it either produces its type or it fails, and that's pretty simple. An expression either type checks or doesn't. There's really nothing more to it. Evaluation, it produces a value, or it will produce an error or an infinite loop, both undesired. But in most cases, you want it to produce a value. Okay, then we've looked at values, or excuse me, variables. The syntax for variable is any sequence of letters, digits, or underscores, but you cannot start with a digit. Okay, and the way we type check our variables, we look for the type in the current static environment and return that type. And if it's not found, it fails. So say if we tried to add two types that couldn't be added together, it would have failed on our example for variable z. Instead of becoming an int, it would have just plain failed. Okay. And on evaluation, our variables look for the value in the current dynamic environment, and we return that value. Okay. So if it type checked, it will be there. It will be in the dynamic environment. If it had already type checked, so we know it's there, and we simply return that value. Okay. Variable bindings, we've also seen a lot of that now. The syntax for that, we have a variable keyword, which is of any type, and we have a name, an assignment operator, which is the equal sign, followed by an expression and a semicolon. Here's an example with an int width, which is assigned to the value of 12, followed by the semicolon, which makes it a statement. Okay. And the way we type check our variable bindings is we type check the expression E, and we add that to the current static environment. If it type checks, it gets added, and if it fails, then it stops right there. Okay. And the way we evaluate it is we evaluate the expression, and we add that value to the current dynamic environment. Okay, pretty basic. In addition, we've seen that now. So let's look at that a little deeper. The syntax, we have expression 1 plus sign and expression 2 on the right. The way we type check it, if expression 1 and expression 2 have type T, then E1 plus E2 has type T. In other words, if they both have the same type, then it will have that type. Now, if they have a different type, there are different rules in C# for that. Suppose you have an integer here and say a string here. It would actually return a string in that particular time. If you have a float on one side and a string on the other, or excuse me, even a string, it would produce a string. But let's say it had an int and a float, it would change the float to, the int to a float. Okay, there's different rules in C#, but let's just say if they both have the same type, then the value of that expression will be that type, or yes. And then the way we evaluate it, if E1 evaluates to V1 and E2 evaluates to V2, these are values, then E1 plus E2 evaluates to the sum of value 1 and value 2, which it's really just a very long way of saying that E1 plus E2 evaluates to the sum of the values of those expressions. Okay. And that's really all the theory I want to do on that. I want to kind of keep it short if I can.